All right, this is our third day at using the rational root theorem. We're just gonna be solving some more of these polynomial equations. So this is a little bit of a review. This is similar to what we did yesterday. It says find all the roots of this cubic equation. And then it gives us a hint. The hint says 1, 5, or -5 is a rational root. So I'm telling you, one of these three is going to be the one that works. But just because I'm telling you which three could possibly work, I still want you to list out that list of possible rational roots. I always want to see that. All right, so we're going to do that first. So let's generate our list. Even though from that list, I already know which three might work, I still want to see that whole list. So we're looking for a rational root. So it's going to be in the form P over Q, where P is factors of your constant term, which is -10. And then Q is factors of your leading coefficient, which is 4. So let's list out all the factors of 10. So we got 1 times 10, 2 times 5. And then, of course, we got the positive and negative of each of these numbers. Let's do the same for 4. So we have 1 times 4, and then 2 times 2. And then we get the positive and negative of each of these numbers. So if we have a rational root, it's going to be in this format, where I can only have 1, 2, 5, or 10 on top, and 1, 2, or 4 on the bottom of your fraction. So now let's generate that list. Again, I want to see this every time, even if I give you a hint like I did on this one. So what do? Well, we're going to take all the numbers on top. Okay, let's take all those. So let's take 1, 2, 5, and 10. Put all these numbers over our first number on the bottom, denominator on the bottom, 1. All right, so if we take 1, 2, 5, and 10 and put them all over 1, we're just going to get the same numbers back. So when we put 1 over 1, we just get 1, 2 over 1 is 2, 5 over 1 is 5, 10 over 1 is 10. So now we're going to take those same numbers and put them over 2 and see if we get any new ones. Let's put these over 2 and see what we get. 1 over 2 is 1/2. That's not on my list, so let's add it to the list. 2 over 2 reduces down to 1. I already have that on my list right here. 5 over 2 is a new one, so let's add that to our list. And then 10 over 2 reduces down to 5. So the last thing we got to do now is take them all and put them over the 4 and see if we get any new ones to add to our list. So 1 over 4 is 1/4. That's a new one. 2 over 4 reduces down to 1/2. We get that on right here. 5 over 4 is a new one. And then 10 over 4, or 10 over 4 reduces down to 5/2. And we have that there. So here's our list. Now, if we were just doing this without the hint, we would have to find one of these that works. We don't know which one works, but we were given a hint. It says either 1, 5, or -5. It's going to be one that works. So let's test out 1. Let's see if 1 is going to be the one that works. So remember, we're going to use synthetic division to do this. So let's look at our original equation we're trying to solve. We got to the 3rd power, to the 2nd power, to the 1st power, to the 0 power. So none of my variables are skipped over. My coefficients are 4, positive 16, negative 22, negative 10. So let's write that out. 4, 16, negative 22, and negative 10. right? And we're going to use synthetic division on this. So we're going to draw a line under it, drop down the first number under the line, and then multiply by the number in the box. So we're going to take 1 times 4. 1 times 4 is 4. 16 plus 4 is 20. 1 times 20 is 20. Negative 22 plus 20 is negative 2. And then 1 times negative 2 is negative 2. We get negative 12. We're trying to get the remainder to be 0. So since it's negative 12, we know 1 is not the one that works. So we could cross off the 1. All we got to do, since this is a cubic equation, is we just got to find one of them. Because we are trying to get it down to an equation that we know how to solve. And we know how to solve quadratic equations. So that's our goal. So let's test out 5. See if 5 is going to be the one that works. So let's list out the coefficients again. We got 4, 16, negative 22, negative 10. Bring down the 4. 5 times 4, 20. 20 plus 16, 36. 5 times 36, 180. 180 minus 22, 158. 158 times 5, 790. So we end up with 780. That was pretty obvious that this one wasn't going to work when we got towards the end. So it looks like it's going to be negative 5. That'll be the one that works. Just knowing negative 5 works still doesn't do you any good. You still got to do the synthetic substitution or synthetic division here. So we find out it's going to be negative 5. So let's see, what do we get? Let's make sure it's confirmed that it's negative 5. So we got 4, 16, negative 22, negative 10. Draw a line under there. Drop the 4 down. Negative 5 times 4 is negative 20. 16 plus negative 20, negative 4. Negative 5 times negative 4, positive 20. Negative 2 plus 20 is negative 2. And then negative 5 times negative 2 is going to be positive 10. And we get the remainder of 0. So, remember we started with a cubic equation. So now what we have here are my coefficients of my quadratic equation. Because remember, when you use synthetic division, it's always 1 degree less. So this is your x squared term. This is your x term. This is your constant. And remember, this was my remainder. And since the remainder is 0, it goes into it evenly. It factors into it. So here's our equation that we need to solve. 4x squared minus 4x minus 2 is equal to 0. So this is a quadratic equation. We have tons of methods to use to solve it. We can try to do it by factoring. We can try to do it by square root method or quadratic formula. But one thing that I notice here is this whole equation is divisible by 2. So if you ever have that, where there's a number that divides everything in the equation, you can make the equation simpler by dividing that whole equation by that number. It's still the same equation. So what we're going to do is we're just going to divide this all by 2. And then when we do that, we get 2x squared minus 2x minus 1 is equal to 0. So I'm going to see if I can factor this. Can I factor it? Well, to factor it, we do the product sum test. So let's take 2 times negative 1. 2 times negative 1 is going to be your product, which is negative 2. Your sum is the middle number, which is negative 2. So are there two integers that you can multiply together to get -2 and add to get -2? No, there isn't. So what that means is we're going to have to solve this by using the quadratic formula. So again, just a reminder, here's the quadratic formula. And remember, you get your values from the standard form. The standard form is ax squared plus bx plus c equals 0. So let's see. So we got the opposite of b. So b is -2. The opposite of -2 is going to be +2. Then we got b squared. So -2 squared is 4, right? So we'll put a 4 here. And it's times, and then we got -4 times a times c. A is 2. C is -1. And this is all over 2 times a. 2 times 2. So here we go. We got 2 plus or minus on the bottom. 2 times 2 is 4. I got my square root. What's under the square root? Well, we got 4. And then we got -4 times 2 is -8. Times -1 is going to be +8. So we get the square root of 12. So now we need to reduce the square root of 12. Square root of 12, what perfect square divides it? 4 does. Times 3, right? So we can break this down to the square root of 4, square root of 3. So now we got 2 plus or minus 2 square root of 3 over 4. And that's our other two roots. But we just gotta make sure it's always simplified. These numbers that are on the outside, form like a triangle. If there's a number that goes into all 3 of them, you gotta reduce it. So we can divide these all by 2. Alright, so a recap here. Here's what we have. Remember, we found one rational root of this equation. The rational root was -5. So that's one of the roots. And then here's our other 2 roots. We got 1 plus 1 square root of 3 over 2. And we got 1 minus 1 square root of 3 over 2. Here are our 3 roots, because it was a cubic equation. The first root is rational. The last 2 roots are irrational. Okay, let's take a look at one more problem here. Again, these problems are long, so you're not going to have a whole bunch of these on today's assignment. Look at this one. This is a 4th degree equation. So what does that mean? We're going to find 4 roots to this equation. So we're going to start it off the same way we did the last example. We're going to generate that list of possible rational roots. Again, to be rational, it means you can write it as a fraction using only integers. So we're going to look at factors of -21 over factors of 6. So all the factors of 21, we got 1 and 21, 3 and 7. And then we got plus and minus of each of these. Then we're going to do all the factors of 6. We got positive, -1, positive, -6, positive, -2, positive, -3. Okay? So let's list this out. So again, here's what we're going to do. We're going to take all the numbers on top and then write each of those numbers over the bottom numbers and then reduce our fractions. This is how we're going to generate that list of possible rational roots. Okay? So if we take each of the numbers in the numerator and put them over 1, we're just going to get the same numbers back. So we got plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. So now we're going to take them and put each of those numbers over 2 and see if we're getting new ones. So 1 over 2 is a new one, 1/2. 3 over 2 is a new one. 7 over 2 is another new one. And then 21 over 2 is another new one. Now, let's put them all over 3. I'll get plus or minus 1/3. We get 3 over 3, which is 1. That's one that we already have. Plus or minus 7/3. 21 over 3 is 7. We already have that one. So now let's write each of the numerators over 6. See if we end up with any new ones for this one. 1 over 6, that's a new one. 3 over 6 is 1/2, we already have that. 7 over 6, we don't have. And then 21 over 6, well, 21 over 6 reduces down to 7/2, we already have that one. All right, now, when you have a cubic equation, you just got to find one of these roots. Because when you have a cubic equation, you get it down to a quadratic equation. When you have a 4th degree equation, you got to find 2 of them. Because first you got to get it down to a cubic, and then you got to get the cubic down to a quadratic. And then again, we don't know which one works unless I give you a hint. So if I don't give you a hint, my hint is always start at the beginning. So let's start with 1. So let's test 1 out. Let's hope we get lucky and we find one really quickly. So we're going to list out the coefficients of my equation. Make sure before you list it out, make sure none of the variables are skipped over. We got x to the 4th power, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. So none of my coefficients or none of my variables are skipped over. So list out the coefficients. Make sure you don't leave off any signs, because you don't want to do all this work and just make a silly mistake. All right, so let's drop the 6 down. 1 times 6 is 6. Negative 5 plus 6 is 1. 1 times 1 is 1. We get negative 64. 1 times negative 64 is negative 64. What do we get here? 21. And then 1 times 21 is 21. Oh, wow, we got lucky. Okay, this normally doesn't happen, but if it does, that's really good. We got lucky. We found one already that works. So it's just circle that. So we know 1 is a root to this. But remember, we're trying to get it to a quadratic equation. What did we just turn it into? We just turned it into a cubic equation. So let's write our new cubic equation. So 6x cubed plus 1x squared minus 64x plus 21 equals 0. Sometimes when you do this step, you can eliminate some of those possible rational roots. But this, if you look at our original equation, it starts with a 6 and ends with a 21. Our new equation that we just found, our cubic equation, still has a 6 up front and 21 on the end. So we can't eliminate anymore. So we still got to choose from this list. All right, so we tested 1. So now let's test negative 1. But when we're testing negative 1, we're not testing it into the original equation. Because we're trying to get it down to a quadratic equation. So what we're going to use is we're going to use our coefficients that we just found of our cubic equation now, when we're using synthetic division here. So we got 6, 1, negative 64, 21. Let's hope we get lucky again. Find one that works. So drop the 6 down. Negative 1 times 6 is negative 6. 1 plus negative 6 is negative 5. Negative 1 times negative 5 is positive 5. Doesn't look like this one's going to work. Alright, here's what we got. 64, negative 64 plus 5 is negative 59. We have positive 59. This is not 0. Alright, so we know it's not negative 1. So what's the next one on our list after negative 1? 3. So let's try out 3. Let's see if 3 is going to be the one that works. Alright, so when you're doing this on the homework assignment, I want to see where you are testing. I don't want just to see the ones that are going to work. I want to see the ones that don't work. So show me all the steps. Don't leave out any steps. So let's see if 3 is going to be the one that's going to work. So we drop the 6 down. 3 times 6 is 18. 1 plus 18 is 19. 3 times 19, what's that? 19 times 3 is 57. And then we get negative 7. 3 times negative 7 is negative 21. We get a remainder of 0. All right. We found our second root. So far, here are the roots that we have. We found 1 worked, and we found 3 works. Remember, this is a 4th degree equation, so there's 2 more roots, okay? But now we got it to a point where we can find the last 2 roots easier. Because remember, our goal is to get it down to a quadratic equation. We started with the equation to the 4th power. Then we got it to this equation, an equation to the 3rd power. Now we use that equation to the 3rd power to get it down to an equation to the 2nd power. So here's what we got now. 6x squared plus 19x minus 7 is equal to 0. So we got it into a form that we can solve now. We can try to do it by factoring. I don't know if it factors or not, but we can try. It might actually factor. Let's see. 6 times negative 7 is negative 42. Are there 2 numbers that multiply be negative 42 and add to be 19? It looks like, what about 21 and negative 2? 21 times negative 2 is negative 42. 21 plus negative 2 is 19. So what that means is we can solve this by factoring instead of doing the quadratic formula. So let's do it by factoring. So let's do slip and slide. So let's take our 6, our leading coefficient of 6, and slip it to the back, multiply by the 7 to get 42. So now we got this quadratic equation that has a leading coefficient of 1. So we can put x and x down. What 2 numbers multiply be negative 42 and add be 19? Positive 21 and negative 2. So let's put plus 21 and minus 2. What are we using? Slip and slide. So remember, we slip the 6 to the back, so slide the 6 back into the problem, and then reduce these. 21 over 6 reduces down to what? Divide them both by 3, so 7 halves. 2 over 6 reduces down to 1/3. All right, so now we can set both of these factors equal to 0 so we can find the last 2 roots. So we end up with x equals negative 7 halves and x equals 1/3. So what are the roots? What was the very first one we found? Wasn't it 1? Right here, 1. That ended up a remainder of 0. What was the second one? 3. And then we find the last 2. So the roots to this polynomial equation are 1, 3, negative 7 halves, and 1/3. And all 4 roots are what? rational. This has 4 rational roots. And on that list, we see that all of these roots that we ended up with were in our list of possible rational roots. We just had no clue which one was going to work. We got lucky that they were in the beginning. So when you're doing these problems, if I don't give you no hint, just start from the beginning and go from left to right. That's my hint, unless I give you one.